Hi, everybody. Welcome to Math with ACE. We are going to be calculating more probability with listing sample spaces, calculating the probability using and, or, and given. We are dealing with a fair six-sided die. That means that each side is equally likely to be chosen, and the options are 1, 2, 3, 4, 5, and 6. We're going to describe each sample space of the events that are given, and then also calculate that probability. So for the first one, event T, the outcome is 2. So T, the sample space, is just the number 2. And if your total sample space is 1, 2, 3, 4, 5, and 6, that's 6 outcomes, which means the probability of T is going to be 2 out of that 6. You could reduce this to a third. You could turn this into a decimal if you want, or a percent. I'm just going to leave it as is. Event A is the outcome is an even number. So of our total sample space, the even numbers are 2, 4, and 6. And then the probability of getting an even number, there's 3 out of the 6 total, or 1/2, 50, 0.5, 50%, or 0.5. Event B are the outcomes less than 4. The numbers that are less than 4 are 1, 2, and 3. And the probability of having those 3 numbers is 3 out of 6. Now we're moving on to complement. Remember, complement is not whatever it is. It's not like complement the right thing to do. It's the complement of the event. So if you have event A, the complement is not A. So the complement of A is listed as A prime. And so if A is all of the odd and all of the even numbers, then not A would be all of the odd numbers. And the probability of being all of the odd numbers is 3 out of 6 as well. Evens and odds make up the total sample space. 3, 6 plus 3, 6 equals 6, 6, which is also the total sample space. A given B. This means out of the B's, how many are in A? So the B's, remember, are 1, 2, and 3. There are only 3 options, which means that our denominator needs to be out of 3. And then how many of those in B are also in A? Well, A was even, and there's only 1 even number there. So the probability of A, given that you're in B, is 1 over 3. Let's do it the reverse. What is group A? A was all of our evens, 2, 4, and 6. So the probability of being in group B, given that you're in A, well, A also still had 3 outcomes, but B were the numbers 1, 2, or 3. 2 is only one of those. There's only one that was in B that was also in A, starting with the A group. A and B means it needs to be in both A and B. Well, the only number, as we see, that is in A and B is 2. Listing that sample space first. And then the probability, we're not talking about a subset here. We're just talking about the probability of A and B. There's only one of those out of 6. So our denominator doesn't change. Our total sample space doesn't change. A or B is all of the things that are in A, as well as all the things that are in B. So all the things that are in A are 2, 4, 6. And then B is 1, 2, 3, but I'm not going to rewrite 2. I already have it included. I don't need to write it again. That's 5 numbers. It's everything but 5. The probability of A or B is then 5 out of 6. What about this next part? A or not B. So A, all the things that are in A, which is 2, 4, and 6. And all the things that are in not B. So B is 1, 2, 3, which means not B is 4, 5, 6. We've already listed 4, we've already listed 6, so all we need to do is include 5. And then that probability is 4 out of 6, because the 2, 4, 5, and 6 is 4 numbers. N is the outcome as a prime number. Well, you need to know what a prime number is to be able to answer this question. A prime number is divisible by 1 and itself. which means that 1 is not a prime number. 2 is a prime number. It's the only even one. 3 is a prime number. 4 is not a prime number because it's divisible by 2. 5 is a prime number, and 6 is not divisible, or 6 is divisible by 2, so it's not prime. And that is 3 out of my total 6 outcomes. And then lastly, I. I is the outcome is 7. Well, I can't just write 7 for my sample space because 7 is not in the original sample space. So my sample space is actually empty. And we can write the null set by putting a 0 with a line through it to represent that it's empty. The probability of I is then 0 out of 6 because we can't have it happen. Let's move on to one more example using a two-way table. This table describes the distribution of a random sample of 100 individuals organized by sex at birth and whether they're right or left-handed. So we have right-handed and left-handed. We're not including ambidextrous people here. And we have males or not males. So M is male, N is not male, R is right-handed, and L is left-handed. So we're computing probabilities based on this. There are 100 total. They did tell us that there were 100. If you were to add them together, like the males, you would see that we had 52. Not males is 48. That adds to 100. Left-handed is 13, and right-handed is 87. That also adds to 100. So our denominator is going to be 100 unless we're doing something conditional. The probability of being a male total, not a male and right-handed or male and left-handed, there's 52 males out of 100. Again, you can reduce, you can turn it into a decimal, you can turn it into percent, totally up to you. I'm just going to leave it like this. The probability of not male total, not a subgroup, is 48 out of 100. Males and not males totals to 100. The probability of right-handed is 87 out of 100. And the probability of left-handed is 13 out of 100. Left-handed and right-handed sum to 100. It's a total sample space there. Okay, let's get into some different questions. M and R, what does that mean? We are looking for male and right-handed, so we need to go into the table to answer this question. Males are here, but the males that are right-handed are the 43. So I'm talking about 43 out of 100. Let's use that same approach for not male and left-handed. My not males are here, and my left-handed, there were 4. So there were 4 that were male, not male and left-handed out of 100. The probability of male or not male would be adding the males and the not males together. All the males, all the not males, and I get 100 out of 100. Those are disjoint or mutually exclusive events. M or R, so the probability of male or right-handed. I'm going to erase my notations really quickly because I want to show you something. Male, that's the first thing that we're doing. Or right-handed, that's the second thing that we're doing. If you notice, there is a square in here that is highlighted twice. If I was to just add 52 plus 87 for all of the males and all of the right-handeds, I get 139, which is more than we have in the group. And that's because we double counted those male right-handers. So what I need to consider is all of the males, which is 52 out of 100, plus all of the right-handers, minus what they had in common. That's going to be the 87 plus 9 which is 96 out of 100. It's everybody except the not male left-handers. It's really important when you're doing an OR in a two-way table that you don't double count. N or L, so not male or left-handed. Again, we don't want to double count. So not males is 48 total out of 100, plus left-handers is 13 out of 100, but there are 4 that are common to both that I need to subtract. So what that's going to give me is 57 out of 100. My last few are, I'm going to put them up here so we can see the chart at the same time. We have a complement and we have conditional. Not M, so not male. All of the not males, that's 48 out of 100. But now I'm into conditions. And remember, it's the second letter that tells us what our condition is. So I want to know the probability of being a right-handed given I'm a male. So here I am. I'm focusing on males only. That means that my denominator is 52 because I only care about the males. Of those 52, how many were right-handed? In the highlighted column, you will see that 43 were right-handed. That's how you approach it. Focus on the condition that you're given, and then that's your denominator. What is the numerator is how many are in the first group. So how many right-handers were in the male group? Let's use that same approach for the next one. There's a typo. This is supposed to be an N. How many not males given that they are left-handed? So let's focus on the left-handers. That means there's only 13 of those. And of the 13, how many were not males? 4. Notice that all of the other problems, the denominator was 100. It's not until you give a condition where you're shrinking your sample size. Finally, given of the left-handers, finally, what is the probability of being left-handers given that you're not male? So of the not males, of the 48, how many were left-handers? 4. Hopefully this helps with determining and an or and given conditions with two-way tables as well as with different sample spaces. Thank you.